So, good morning, good afternoon, and good evening to all the attendees we have in the call. My name is Jochen Regenauer. I'm the moderator today. This webinar is about the Trosifol WinSLT, the optical and solar calculator. So, this is the first of 3 training sessions about the Trosifol online tools. And they are designed to help with the specifications and the choice of products to use for certain laminated glass applications. Just a few words to the housekeeping. Your audio and visual has been turned off to add the quality of this presentation. There's a facility for you to raise any questions at the bottom on your screen on the right side. There's a small bubble which enables you to post comments. If we have time, I will go through some of these at the end, or we will definitely individually reply to everyone. So this session is also recorded, and for those who are unable to attend and for those that request a copy, please send us an email and then you get the recording. Because this is a live presentation, I apologize in advance for any technical hitches. Now I'd like to introduce you to our today's speakers. Warren Charles is the American Technical Consultant Manager. He has a master's degree in chemistry. He started more than 10 years ago directly with the glass laminators, and he has significant expertise in lamination process. In his current role, Warren is focusing on structural, security, acoustical, and hurricane applications for laminate with safety glass. And he's also involved in the industry organizations and standard committees like the ESTM. Now I'd like to hand over to Warren. So Warren, it's your stage.
All right, thank you for the introduction, Jochen. Good morning, good afternoon, good evening to all of you out there. So let's get started. Today we're going to discuss the Trosifol WinSLT. We're going to look at basically the the background of light and what we're looking for in the window calculations, how to run the calculation with the program, and then the report function. But first, let's get started with a little bit about Kuraray. So a lot of you may be familiar with Trosifol, but not necessarily with Kuraray. And chances are you have already touched some product that uses one of our many different chemicals in your day-to-day. Whether it's a filling that you have in your mouth for your teeth, or you used a water-soluble film for, say, your soap in your dishwasher. Kuraray is a company that makes a lot of different products, and they're all over the world. But today we're going to focus on Trosifol. So what is Trosifol? Trosifol is Kuraray's business that is specializing in PVB film and Centriglass films for the laminated safety glass market. We offer these interlayers for structural, acoustics, decorative, even UV protection. With seven manufacturing sites, 5 R&D labs, and 18 sales offices worldwide, we are positioned very well to service any of your needs. So this is the first of a 3-part series on the suite of online calculation tools that we have. We have the Trosifol Sound Lab app. This is for determining sound insulation values, so STC, RWs. We have the Trosifol Glass Global. This is a structural calculator for wind load and even line loads. And then the Trosifol WinSLT, which is the calculation of energy and light transmission for solar radiation and temperatures of glazing when combined with sun or heat protection. So let's start with a little bit of background about the radiation from the sun. Electromagnetic radiation comes from the sun and is transmitted in waves and or particles at different wavelengths and frequencies. This broad range of wavelengths is known as the electromagnetic spectrum, and the spectrum is generally divided into 7 regions in order of decreasing wavelength and increasing energy and frequency. These are, for instance, gamma rays, X-rays, UV light, visible light, infrared, microwaves, and even radio waves. But what we're really focused on is the UV to the infrared. When it comes to the UV light, fortunately for us, this Earth's atmosphere protects us from the vast majority of the harmful UV, such as the UVC. It allows a little bit of UVB and all of the UVA that comes in. The UV light is very beneficial to many organisms and plants, but it can be harmful to us, such as skin cancer. When we're looking at glass, though, we're looking at how the solar radiation comes through the glass. So the UV light, the visible light, and the infrared light. And the vast majority of it is the visible light, which is great for us because that's what we're able to see. But we do have to worry about the UV light and the infrared light, which can lead to fading of carpets or upholstery behind the glass or heat transfer from the infrared light. The solar radiation can be, when it hits the glass, can be reflected outward, or it could be absorbed by the glass itself and then transferred as heat inside the room or outside, or it could just be transmitted straight through. And so the intent of solar control glass is to reduce the amount of energy that is transferred straight through. There are 2 types of solar control glass. There's the absorbent type and the reflective type. The absorbent solar control glass are the glass that's tinted, usually by metal oxides during the manufacturing process. The typical colors you see are bronze, gray, green, and even blue. Because they're tinted and they're a lot darker, they absorb the energy from the solar radiation. But this, unfortunately, makes them very hot and they tend to radiate the heat outward. So you could be standing next to the glass on the inside and feel the heat radiating off of the glass. The other type of solar control glass is the reflective. So this is a special coating that when the sun's energy hits it, it reflects it back outside. This is very beneficial because it reduces the amount of energy that's coming through. And also the glass doesn't get as hot because it's not absorbing it as much. But unfortunately, this could cause some problems to nearby objects, such as melting if there's issues with the concavity of the glass. Another type of solar control is the low E or the emissivity coatings. Emissivity is a measure of the efficiency in which a surface emits thermal energy. So how well does it emit the energy, the heat that's from it? So low E coatings reflect the heat, or the long wavelength IR. It doesn't block the solar radiation, but it can be used with solar control glass. And it's manufactured by 2 different methods. You have the pyrolytic method and the sputter coat method. The pyrolytic method is made during the manufacture of the glass itself. So while the glass is still hot, it's sprayed on the glass through a chemical vapor deposition. So this makes a very hard coat that's very scratch resistant and permanent. It makes it easier to handle, transport, and stack. And for this reason, it can be used for monolithic glass, or it could be used in an IG on the number 1, number 4 surface where it's exposed to people touching it, as well as the number 2 and the number 3 surfaces. Some drawbacks is it could have splotchy coverage, and it doesn't quite perform as well as the sputter coats or the soft coats. So the sputter coats is made after the glass has already been made and cooled down. So it's a separate process that's offline. And it's called an MSVD process, or a magnetic sputter vapor deposition process. And because it's made after the fact, it's not as permanent or scratch resistant as the pyrolytic. So it's typically referred to as a soft coat, and it can be easily scratched. So for that reason, it must be used in an IG unit on the number 2 or number 3 surface where it's not in contact with the outside world. The benefit of the sputter coat is that you're able to create spectrally selective coating, so you can make multiple layers of different types of material so that you can design the coating specifically for an area. Because of that, it allows better solar heat gain values than the hard coat. So what does all this mean? So when it comes to designing your window, you have a bunch of different options that you can use based on where your application is. So say you're in a cold climate, you really want to reduce your heating costs. You don't really care too much about cooling. You care more about heating because it gets cold then. So in that case, you could put a low E coating on the number 3 surface, and that would prevent the heat from exiting the building. So it will reflect the heat back into your building. You can also combine this with clear glass so that you have a passive solar heat gain window. So the sunlight can come through, and then it'll be trapped in there because the coating won't let it to escape. In hot climates, you want the opposite. You're not really concerned about heating the house. You're concerned about cooling and keeping the inside cold and not the heat outside. So for this, you could put a low E coating on the number 2 surface, and you could also combine it with a solar control glass so that you have the best of both worlds and you're eliminating any type of heat or thermal transfer of the outside temperature, outside radiation into the house. And all of this is what is required in a lot of areas, a lot of countries around the world. They require the solar calculations to be performed on the glass itself. So for instance, in North America, we require the solar heat gain coefficient, the U factor, so how well it's insulated, as well as the visible transmittance, and even the UV transmittance. And in other parts of the world, they have similar requirements as well. So you'll need to check with your local codes to find out what levels you're actually trying to get to. So that brings us to our Trosifol WinSLT calculator. So this is a tool that we developed to calculate these different solar and optical properties of laminated glass. It's available in multiple languages, 5 of them: English, German, French, Italian, and Spanish. It references 2 different standards. You have the EN 410 for the European standard and the ASHRAE for North America. It works very well for clear or low iron glass, but coated glass not so much, mainly because we have generic coatings in the program instead of having every single coating that's out there right now. And there is some limitations for the translucent white interlayers. They are limited to just 1 layer, so 0.76 millimeter or 0.30 inches. The Trosifol WinSLT, like the rest of our tools that I mentioned, are available on our website at trosifol.com under the Architects and Engineers corner. And they're also available as an app for your smartphone. So just look in your phone's app store and search for Trosifol. And there you'll see all 3 of our apps for the WinSLT, Glass Global, and the Sound. So let's start. This is the front screen that you would see when you download the app or you go to the website to look at it. It's a pretty simple user interface. And the first thing we're going to do is go to step 1. And here you get to select what you want to, how you want it to look like. So you have your language that you can select between the 5 that I mentioned. You can select what standard you're trying to calculate to, whether it's ASHRAE as shown in this example, or the EN standard. And then you can select the units, so imperial units or metric units. The second step is to now pick out which type of configuration you want. There's a lot of different choices from just a single laminated glass. You could do a triple laminated, IG with the laminate on the outside, on the inboard. You could do a double laminate, triple or double laminate IGU. You could do a triple IGU with 1 laminate or 2 laminates. So there's a lot of different options as far as the makeup goes. And it's pretty simple. You just highlight your cursor over the little radio buttons and hit select, and then it'll automatically change. Step 3, this is where you're actually going through all the details of the makeup itself. So you're looking at your glass thickness, your glass type, whether it's regular glass or low iron glass, the cavity size if you're doing an IGU, what the gas makeup is, and then your interlayer type and your thickness. So you go through each of these drop-down screens and you pick what you want. So in this case, this is a insulated unit with the lamy on the inboard side. We're doing 1/4 inch or 6 millimeter low iron glass with 1/2 inch or 12.7 millimeter 90% argon spacer. Another 6 millimeter on the inboard side. That's a 6+6 lamy with our Trosifol Ultra Clear. Step 4, now you get to select your coatings and your boundary conditions. So we have 4 coatings that you can select from. You have your sun protective layer. So this is a solar control glass that absorbs or reflects the light. You have the thermal protection, which is a low E coating that blocks the heat. Then you have a combination of solar and thermal and sun protection, which is both a low E coating and a solar control glass. And then there's a self-cleaning coating similar to St. Gobain's BioClean. And then you can select if you're, for your boundary conditions, if you're doing summer or winter. We'll see what this actually does in the report. And then step 5 is pretty simple. You hit calculate, you enter your project name if you want your project name, put in your email address, and then hit send report, and it will send you a report directly to your email. No middleman, no nothing, just straight to your email, and you get a very nice looking report. And that's what we're going to look at next. So this is what the report looks like. So the first thing you're going to see, so this is done with the ASHRAE version. If you chose the EN, there's a couple more figures that you would see. But we'll blow this up. So the first thing you're going to see is the description of the makeup itself. So what glass, what interlayer was used, and also the total thickness of the unit. And then you'll see the graphic of the construction. So this is what it's represented to be, as well as showing the temperature gradient. So this is where we picked that summer or winter. So it'll define what the outside temperature is based on summer or winter, and then what the internal temperature will be based on it going through the glass. The next section that we see is the transmission of UV light, visible light, and the solar. So these are in decimals, so you need to multiply by 100 to get to percentages. So in this case, 0.78 for the light transmission, multiply by 100 to get 78% total light transmission. On this side of the report, now we're looking at the reflection and the absorption. So we're looking at the visible light reflection on the inside, on the outside, the solar light reflection on the inside and the outside. And again, these are in a decimal, so you'll need to multiply those by 100 to get your percent. The next section of the report, so now we're getting into the solar properties. So we looked at all the optical, now we're looking at the solar, so your shading coefficient, your solar heat gain coefficient, the U value for winter and summer. So these they're expressed as a decimal, but they're supposed to be a decimal. So you don't have to multiply these to get a percentages. And then at the bottom, you have a graph showing the transmittance and reflectance. So the tau is the red line, and that's the transmission. And the rho is the reflectance, which is the green line. So you have a nice graph that shows the percent of the reflection and the transmittance over all the different wavelengths. So like I said, we have 3 apps. They're all available on our website and as an app for your smartphone or your tablet. And you can go to any of your app stores and download them for free. So at Trosifol, we have a team of experts dedicated to helping you with any kind of specifications or consultancy services that you need, such as running finite element analysis for structural calculations with bomb blast. We have a lot of experts in the field that can help laminators to laminate better in case there's any issues, as well as looking at different building codes that are going on throughout the world and other technical support. And then we have our online tools, strength of glass calculator, the WinSLT, which we just went over, and the SoundLab app. In addition, we have some other presentations that have been recorded that you can register for and attend. So dealing with designing with structural interlayers, acoustic interlayers, or UV performance, and even marine applications with laminated glass. And last but not least, if you're interested in learning more about outstanding projects, please subscribe to our Laminated Glass News. It's a newsletter that comes out that highlights a lot of different projects throughout the world. And with that, that's the end of this presentation. So now we'll look at some of the questions and try to answer those.
So thank you very much. So far, we haven't any questions on that. So it seems to be everything is clear. So if you like to receive again a copy of this kind of presentation, please forward us an email to trosifolevents@kuraray.com. Then we will send it out individually to you. And
so there is one, Jochen, there's one on the chat from Armando asking about is the ASHRAE standard that you mentioned inside NFRC. Yes, so NFRC references the ASHRAE method, and so that is the North American standard. And the what glass library is our WinSLT using? So it's generic for the glass itself is generic glass, but all of the interlayers are from testing that we have done and have been submitted to all the like optics in Windows. So it's the same data that's in those two programs as well. What about WinLoads? WinLoads is done in our Glass Global app, which is another presentation coming up.
Okay, I do not see more questions.
I think that's it.
So, yeah, thank you all for your attendance and have a great weekend. Stay healthy, stay safe, and hope to see you again. Thank you very much. Bye-bye.